Good morning, everyone. Welcome back to MAC1140. So, in the previous video, I introduced section 5.1, 5.2, rational function and asymptote. And we learned so many things about rational function, right? We even though that we did not go through the graph, but you can graph it by by graphing the asymptote and plugging the value. Then you can graph it easily. And nowadays you have calculator. It's very easy for you to graph rational function. And you also know that graphs of rational function might or may not intersect the x-axis, right? Those intersection point is nothing but the zero of rational function, or sometimes we call the solution of rational function or rational equation if we set f of x equal to 0. And if we set f of x equal to 0, we convert a function to equation. Okay, and the intersection point is the solution of those equation. In college algebra, you learn how to solve very basic traditional rational function. So today I'm gonna go through that again, and I will also give you several more complicated rational equation for you to solve, and that you have to use the naming variable method, the one you already learned in solving polynomial. Okay, so let's get started. Rational equation. Other than rational equation, we also learn how to solve rational inequality. Okay, and for rational inequality, we're going to use the method, the side table, the one we already learned last time. Okay, so first Roman, rational equation. So we have a general approach when you solve rational equation is you have to factor everything as much as possible. Okay, it is factoring the top and bottom as much as you can. Okay, then the second step is you have to find least common denominator. The reason you have to find least common denominator because you want to simplify a rational expression. You want to combine those rational expressions together so that you have less rational expression in your equation. Okay, then bring it back to basic linear equation. Okay, how we're going to bring it back to basic linear? You can use the cross multiply method, or you can combine all the rational so that you have only one fraction only, and when you set it equal to 0, you have the top equal to 0. Okay, then you can do that. Okay, but this is very general approach. Sometimes you can do this, sometimes you can do that, or you have to be flexible in solving equation. Okay, so let's jump to the first example, the one you have been introduced when you had a college algebra. For example, I have something like this. I have 2x over x minus 4 minus 3 over x plus 2 equal x squared plus 14 over x squared minus 2x minus 8. Okay, what if I have something like this? Yes, this is a rational equation because I see that all the term is in fractional form, and you have variable under denominator. That's the most important thing. When you have variable under denominator, it becomes rational equation, because sometimes you see fraction but it's not rational equation because the variable is not under denominator. So in this case, where variable is under denominator, this is very typical example of what we already learned in college algebra. So I'm going to try to use the general approach here, which is I try to factor everything out. So on the first term there's nothing to factor, the second term there's none, but the last term you see that on the top we cannot factor it, but at bottom we still can. The bottom we still, hopefully we can, right? Yeah, I think so. So we have to factor this. So I'm gonna just keep all of this for the time being, and I'm gonna factor the bottom here. So if I factor the bottom here, so everybody know how to factor, and -4 plus 2, right? Okay, so you see that you have -4 plus 2, you have x plus -4, x minus 4 over here, x plus 2 over here, that we can combine. So to find LCD, so I'm going to find LCD between these two fractions here. You can find LCD for all three fractions, it doesn't matter, okay? But it's up to you. Okay, so I'm going to find LCD for the first two fractions only. So the LCD x minus 4, x plus 2. So everybody know how to find LCD. So I'm not gonna go through this too much. Okay, so I'm gonna have this again over here. Okay. Okay, so you see that after I find LCD, I see that I simplify the equation that has three fractions. Now we have only two fractions, right? You have only two fractional expression. Okay, and it has the same denominator. That's the most important, because this has the same denominator. You can do so many things. Okay. Of course, over here we know that x must be different from 4, x different from -2, because if it is -2 is 0, if it 4 will be 0, it doesn't make sense, right? So when you solve equation, and by the end of the by the time you get the final solution, you have to compare with this. Okay. Okay. So because this has the same denominator, so I just go ahead and throw away the denominator. So so I have the numerator only. Okay, numerator only. All right, then I can void them, right? So right now I bring it back to the very basic linear equation, the very basic quadratic equation. So I'm gonna put a basic quadratic. Okay, so 2x squared minus plus 4x minus 3x plus 12, I void them, x squared plus 14. So I subtract both sides by x squared, so have x squared, 4x minus x is x plus x, 12 minus 14, -2 equal to 0. Okay, so then I can factor this. So let's see, we can factor this, and so you have x minus 1 and x plus 2 equals 0, right? And from here we can use zero product property. So x minus 1 equal to 0, or x plus 2 equal to 0. Then this is implying x equal 1, x equal negative equal 1, x equal to -2. And you see that x equal to 2, it turned out to be 0 at the bottom. So this one is extraneous solution. I mean the one we're not taking. So the only solution we have is x equal 1. Okay. So this is a very typical example of what you already learned in college algebra. So let's do something with more complicated one. So the example 1 is example 2. Let's deal with something more complicated, and let's see we can apply the general approach to solve this rational equation or not. Okay, how about this? This is very interesting problem right here. Let me see. we have a lot of different type of rational inequality and rational equation. You can look it up online and then see. Okay, what if I have something like this? What if I have 3 minus 3x squared over 5x plus, over here we have 5x equal to 2x squared plus 3 equal to minus x. It is rational equation. Yes, the answer is yes, because you see x under denominator. Okay, can we apply the general approach? Okay, we apply the general, which is we try to factor them out, and we find LCD. Actually, we can find LCD over here. You see that? You find LCD over here, you multiply over here, you multiply over here. Maybe it's gonna, and you multiply LCD over here. So you find LCD for all three fractions of it. So 1, 2, 3, 5. So this is over 1. So there's another fraction right here. You can do that, but the thing that is, it might turn out to be 4th degree polynomial, right? Because just think about that. You find LCD over here. The LCD is 5x times 2x squared plus 3, right? You multiply over here, the top and the bottom, by 2x squared plus 3. It's give you x to the 4th degree. Okay, and you see you over here you multiply by 5x by 2x squared plus is 4th degree. So you might end up with the 4th degree polynomial, which is you have to use syntactic division or long division, or you have to use the factor Miranda theorem and factor theorem. You already learned the first section, the first chapter. Okay, if you might get the final answer if you really patient. I mean, that's one of the approach, right? We see that is there any other approach to solve this equation or not? Okay. So what you see in this problem is that this is a very interesting thing about this one. This is fine. I can find out. This is the only difference between this and this is the plus sign. It's the plus sign. So we can do something. We can do something. So what we're gonna do? Okay. Let's see. It's very interesting problem here. Okay. So let's play around with the number, okay? Because I haven't figured it out yet. So that's the reason I stopped this. You know, every time I do the lecture, I want you and me, working on the problem. Not just me. I don't. I want you guys to work on the problem with me. So. If you guys notice, you guys see that if I have 2x squared plus 3 times 2x squared minus 3 over here, this is the difference of square, which is give you what? It give you 4x. It should give you 2x squared squared minus 3 squared, right? Which is 2x squared, which is 4x to the 4 minus 9. Okay, this is the difference of square. So what we're gonna do now? I may name variable so that it looks simpler. Let's see if we can do that or not. Okay. Okay. See the difference here. You see the difference here. So now, I mean, now you see the similarity here, and the difference is here. but in general this is kind of similar to this, right? So I can name variables some way somehow so that our equation become you know, simpler. Okay, become simpler. Okay, how about this? So if I go ahead adding both sides by x, oh, this is, I'm sorry, this should be number, oh yeah, this is number 3. Okay, phi x plus x over here plus phi x over 2x squared plus 3 equal to, okay, so this is 3 and it's not 2. I can split it up into 1, right? Into 2 and 1, right? How about this? Look at that. This is phi x squared. If I find LCD over here, I have phi x squared minus 3x squared is 2x squared. Ah, you see the you see that? Okay, so look at, I have LCD over here, right? So I have LCD also here, so we're gonna have phi x squared minus 3 over here, 3x squared here. I have phi LCD, I multiply by phi x squared, so we give you phi, phi x multiply by phi x squared, so phi x squared here, right? Okay, and over here give you 3 minus 2x squared, or give you plus 2x squared. You see that? Oh, look at that, look at that, look at that. Look at that. So phi x here over phi x here, I'm sorry. So you have phi x 2x squared plus 3 equal to, you see that? So this is the LCD over here is phi x. Okay, you see, after you find LCD over here, they become 3 plus 2x squared. And look at that. At the beginning, it's kind of same, but I mean, instead of plus, we have minus. So I thought that we can use a difference of square over here to name variable. But after I bring number x over here, I simplify that, and it's exactly the same, but it's just a reciprocal of each other, right? So look at that. If I let t equal to 3 plus 2x squared over phi x, so the whole thing over here will be t, right? But the whole thing over here, because this is the reciprocal of this, so this will become 1 over t, right? Because it's reciprocal, and it equal 2. And now what is that? What is that right now? We have what? We convert a very complicated equation to a quadratic right here, because right here we can find LCD and it become a quadratic, huh? So minus 2t plus 1 equals 0. Okay, I find LCD over there. Okay, and over here what we have a quadratic, and we can factor this easily. So this is nothing but t minus 1 squared equals 0. So you have t equal 1 easily. Okay, and if t equals 1 easily, okay, when t equal to 1 easily, you can plug over here, right, to get the x. So you're gonna have 3 plus 2x squared over phi x equal 1. So it'll become 2x squared minus phi x plus 3 equals 0, right? You can do cross multiply over there, so 1 over 1, and then flip it over the phi x, so it become negative phi x. Okay, and now what we have a quadratic again, and we can solve it by factoring. So you're gonna have negative 3 over here plus 1 over here, right? Is that negative 3 plus 1 or 3 over here? I'm sorry, it should be 3 here, negative 3 and negative 1. Okay, it's better. Okay, so we're gonna split up. So you have 2x minus 3 equal to 0, you have x minus 1 equal to 0, so you have x equal 3 over 2, and over here x equal 1. Here you go. There you go. And also don't forget to plug them back in there. After I plug it in, it looks like it's satisfying. Okay, so the example number 2 over here is totally it's not a traditional rational equation you learn in college algebra anymore. Okay, so we have pre-calculus, right? So the rational equation I have over here is you have to do something else. But can we use the traditional approach? Yes, you might. You will, you can, okay, as long as you get the solution. But the thing is that one method is always, if one method is better than the other method, why not using that? Okay, so that example number 2. Okay, I'm gonna give you another example. Okay, so let me flip it over here. Example number 3. What if I have this? What if I have x squared plus 1 over 4x squared, and over here we have 3 times x plus 1 over 2x minus 1. It is rational equation? Yes. How we solve it? General approach work. But you have to be careful. You see, you find LCD over here, you multiply it for x squared, it gives you 4 degrees. Hard to solve. You don't want to deal with 4 degrees. You know, just unless there's no other approach that you have to deal with 4 degrees. Okay. Other than that, you have to think up something else. And the only thing that you already learned is just naming variable. You have to name variable. Okay, and you have to pick wisely so that you can name variable. Okay, look at that. You look at the equation. I don't know if you see anything. Think a little bit. I don't know if you see anything. You see something interesting, or something like it get to your eye right away. You know, something kind of obvious to you, but I mean something something similar, or something different that you can see or not. Okay. You look at the equation, you see it. If you square this, give you this, right? If you get this, you square the x, give you x squared. If you square 1 over 2x, give you 1 over 4x squared, right? So this part over here and the part right here kind of related some way somehow. So we have to name variable. Okay. Solution. Okay. If I square this, it gives you what? It gives you x squared plus 2x 1 over x, right? You see this formula, a plus b squared we already learned. A plus b squared you already learned in college algebra. A squared plus 2ab plus b squared. So give you 2ab plus 1 over x squared. Right? So but over here this is 2x. This is 2x, so this is 2x. Let me see, we squared it, what happens? So 2x will be 4x squared. Right? Okay. And look at that. When you square this, this two little term right here, it gives you the term that is here. Except for this part, right? So you see over here, this one I can simplify. This is the 2x, or 2x to cancel them out, right? So 2ab is a 2x cancel out. So you have x squared plus 1 over 4x squared plus 1. Okay. So if you name variable, you name some way somehow. So look at that. You have to name some way somehow so that it simplify your equation, right? So what will it be? What would it be? Let me see. You already see the similarity, the pattern already. Now you have to name variable. So if I name if I say this is t and this t okay, look at that. So let's play a little bit more over here. So let's rewrite the question. So I distribute, so you have 3x plus 1 over 2x, right? Minus 3. I distribute number 3 in, but I distribute for the whole term. Okay, and okay, then I square look at that. So if I name this is, if this is t here, so this is t, so we this is t, so t, and t squared is this. So what gonna be? What gonna be? Can you see? Can you guys see? If I let t equal x plus 1 over 2x. Okay, so this is your t over here, right? This is your t over here. Your t over here, right? Then it become what? So over here to become t squared equal x squared plus 1 over 4x squared plus 1, right? Okay. So what? So t squared minus 1 is equal to x squared plus 1 over 4x, right? You subtract both sides by 1. Okay, subtract both sides by 1. So you have t squared equal to x squared plus 1 over. So what we're gonna have here? We're gonna have what? We're gonna have over here is t squared minus 1, right? And over here you're gonna have equal 3t, right? Minus 1. Now what? A very complicated equation now that become a very simple one. So this is quadratic, so you have t squared minus 3t minus plus 2 equal 1 equal 0. Okay, then you can factor, so t minus 2, t minus 1 equals 0. Okay, 0. So you're gonna have t equal 2 or t equal 1. Right. And if t equal 2, you plug up here because you need to solve for x. So if t equal 1, then plug it in here. So it become x was 1 over 2x equal 1. Then you will have 2x squared minus 2x plus 1 equals 0. Right. This is quadratic, and you can solve this quadratic easily. You can try to factor them. If it doesn't work, then you have to use quadratic formula, or maybe this doesn't work because when you use quadratic formula, your determinant, the discriminant, yeah, for the b square minus 4 over c, the b square minus 4ac is less than 0. So you have solution, but I mean it's an imaginary solution in this case. So over here you can have no real solution. Okay, the b square minus 4ac is less than 0. Okay, but if you want to get the real one, the imaginary one, you can so using quadratic formula over here, you can get it. Okay, and now for t equal 2, then x plus 1 over 2x equal 2, then you can have 2x squared minus 4x minus 2 minus 4x plus 1 equals 0. How about this one? Do you think this one work? 2, 4, 1. I'm gonna solve it really fast. Okay. Okay, this is work. So if you use quadratic formula, so negative b, so it will be 4 plus minus 4ac, b square minus 16 minus 4ac over 2a, so 2 times 2, so you have 4 plus minus, so 16 minus 8 is 8 over 4. So you factor them out, so you see that, so you have 1 plus minus square root of 2 over 2. Okay, then you have two solutions. All right. I mean, this is real solution, and we don't have real solution here, but we have the unreal, we have imaginary. We want to use quadratic formula to get it. Okay. All right. So that example number 3 is very it's kind of a little bit different from example number 2 and number 1. Number 1 is harder, and number 3 is the way you name a variable is more complicated. Okay. So you see that I'm very flexible in solving rational equation. I mean, I'm gonna just on the test I'll give you something similar to this example only. Okay, the one you have to name variable. Maybe I give you something similar. Really understand how to do example number 2 and number 3. If you don't have any, if you have any question, you let me know right away. Okay. So on the second part of this lecture, I want to show you how to solve rational inequality. Okay. And the way you solve rational inequality, the general approach is that you have to factor everything out as much as possible. Okay, then move when everything to the left side and set 0 on the right side. Okay, then you have to use side table. Okay, for each term. Okay, so we're gonna go through the first example, right, which is not really too hard. Okay.